Let's take the OK day and turn it into great with some mold conversion.
Hey, it's only been okay, Mr. Hall. You've been spying on me?
No, she said it was okay. I'll take her word for it.
It was good. We had good lunch today.
Right on.
We did. I had 2 servings of mac and cheese. Servings.
So,
Yeah, servings.
we're going to start in on these. And remember, we're going to start you off, baby you in. We're going to work you up. And, you know, hopefully by the end of the day, maybe we can get you doing some, you know, good problems. See? Yeah? No?
So let's go for milk feed yams today.
Yeah, probably. I'm looking at the room and everyone just looks blah right now.
What do I need for
That's
this?
just because I
Just
slept
paper?
for
Or
20
do I
minutes
need
in that senior meeting.
Me too. That senior meeting was
How does that not make
Madison Hatfield, Whitney Kirkendall, come to the
Got
office.
that?
Paper,
Got
clear out
that?
table.
I might have that. The mole.
It's okay, no matter.
I don't know if I have that.
And that's good, it's what we did for the last couple days.
I took a
I
There's
think
that,
I
go back and watch
probably got a
this.
table at home too.
Okay, so let's get you guys where you got an understanding of what's going on. I'm gonna try something a little different. Had somebody come to me at lunch, and as I was working with him, I feel like I got an idea to help you out. So, all right, please cover your face. Okay, close. Now, well, remember, we're gonna start easy. So. Oh, let's see. How many moles are in carbon? This is the carbon. So how many moles are in 98.6 grams of carbon? Now, you can have your mole map out.
You wouldn't happen to have another periodic table, would you?
I've got so many, I'm telling you.
I figured so. I just had that in a block.
All you can see.
Oh,
Always have your okay.
thank you.
All right. So, whenever you're doing a mole conversion, formulate your plan. Where we start? By the number. So here's the numbers.
Starting at grams.
98.6. Start with grams, because grams is a unit of mass.
For sure.
So we are starting at mass. Now find where we're trying to go to.
So 1 mole over then.
David Keith Klein, report to room 1070.
You're jumping ahead, but that's a good thing, yeah. So we're trying it up with moles. I'm starting with grams. So the question, can I go from grams straight to moles?
Yes.
Yes.
Yeah, easy peasy, right? So, let's start the problem. Once you formulate the plan, you got the plan, let's execute the plan. So the first thing we do is we take a number, write it down, 98.6 grams carbon. Set it over 1. Now from here is where the conversions are going to come in. So we have to set up a conversion factor. So this is how we're going to convert things. So we're going from mass to grams. So you can look at, we're going from mass to moles. You can look on your mole map if you want to. But something I was doing that a student told me in lunch they liked this more. Where am I starting? Where am I going to?
Mass to mole.
So I'm starting at a mass, I'm starting with grams. So I'm starting there, I'm leaving there. What does that mean? That the grams of carbon goes on the bottom. Where am I going to? So moles go on the top. Either way, you want to reason this out. If you want to use mole map, use mole map. If you want to use that reasoning, use the reasoning. I do not care. Whatever works best for you. So, question. What number is going to go here for grams of carbon?
98.6. Oh, wait. Hang on.
12.01.
12.01.
job. Beautiful.
Transfer mole.
12.01 grams of carbon. Grams of carbon will cancel.
But why 12.01?
Comes off the periodic table. It's the average
I was
atomic
gonna
mass
say,
of
where'd
carbon.
you get that from?
Okay.
Average atomic mass off of the periodic table for carbon. Find carbon right here. It's
Miss
number
Lester
6.
needs the following seniors in her room:
Oh boy.
Hannah Bailey, Nathan Cook, Presta Jude, Ethan Waldron, Samantha Bailey, Austin Klein, Dalton Harris, Michaela Honeycutt, Chandler Atkins, Cameron Sowers, Timmy Green, Chase Rife, and Priscilla Mullins. Please report to Miss Lester's room.
Yes.
How'd you get that?
I just typed in a calculator. 98.6 divided by 12.01.
I need Josh Klein to report to the office, please.
So this is the thing. This is the answer you should get. I have no idea why that number started one blue. So 8.2098 moles of carbon.
Sick.
Woo! Questions?
Why do we use the atomic mass or the average one for the second?
Because that is the part to the conversion factor. 1 mole of carbon
But what's
is
a mole?
equal to 12.01 grams of
He
carbon.
needs a map.
What's a mole?
I gave him.
Oh.
I just didn't fill it in for him. Yeah.
But what's a mole?
Mole is a number, it's a unit that we use, the amount of substance. It takes big numbers and make them small.
A mole is an animal.
That too.
True.
Or make a mountain.
That's
And it's also something on your face.
I was going to say.
Pick a mole.
Alright, so let's do this one. How many molecules are in
That's the answer?
this is the answer
For a mole conversion.
for this problem.
Okay.
I'm coming up with a new problem now.
Why was it as long as yesterday?
Because yesterday was hard, this one was easy.
Tell you what,
That one's
The
not
belly
the
of the
mole.
beast.
that's nice names.
This was milk. Yesterday was steak.
There's baby.
It's a
It
nice
was
fillet.
something.
It's good. How many molecules are in 6.43 moles of water?
I had to look up to make sure you're writing H2O instead of water. And I was right.
I do.
Yeah, I never do anymore. Okay, where are we starting? I give it to you. Starting at moles. How do you know you're starting at moles?
Because it
Because it
says
says
moles.
It says moles. That's what the numbers got.
It's where we're going to start.
Molecules are in 6.43 moles.
Now we're going. Y'all already jumped the gun on me. Beautiful job. Molecules. Y'all make me feel good when you do that, by the way.
What makes you feel bad?
No, like when y'all jump the gun like that and you're saying, no, we're going here, we're going here, we're going here. I want you involved because it gives me your thought process, lets me know where you're at.
I don't know what that's called.
So, how many molecules are in 6.3? 6.43 moles of water.
At least.
Write your number down. So moles of water. Said number 1. I have a question for you. Water is a molecule. Do we need the molecular mass for this calculation?
No,
No. Why not?
because we're not doing mass.
It has nothing to do with mass.
Yeah.
You're in moles,
And
You're
I
going
think
mole?
that
so you don't need to worry about it. So should you ever look at the periodic table on this problem?
No.
No.
No, you don't need it. Don't look at it.
You
Don't
only need it for
confuse
mass.
yourself. You need it for mass. If you ever have mass involved, you need a periodic table. No mass, no periodic table.
That was Spanish.
No mas.
Conversion factor. Alright, I'm leaving moles, so where does moles go? Top or bottom?
Bottom.
Bottom, so 1 mole of water on bottom. You guys help me out, what goes on top?
6.022 times 10 to the 23rd power.
and that is molecules
Excuse me, what?
of H2O. Avogadro's number. That's all we
You
do.
don't have to watch the video.
So,
For sure.
moles of H2O cancel out, leaves us with molecules of H2O, which is what we are looking for. The 6.43 is in the top, and Avogadro's number is in the top. So are we multiplying or dividing? Multiplying. Beautiful job.
Mark halfway through that answer.
So we do that and we get 3.872 times 10 to 24 molecules of water.
How did you get that in the calculator?
I typed 6.43 times 6.022 E23.
How do we get the E again?
Second comma.
No, second column.
E and then just 23.
Need a custodian in the office, please.
Yeah.
This science stuff is crazy. Why?
This is
not as bad
as yesterday.
It's not supposed to. We're building you up to it. Like what I do is I show you the whole pie, and then I give you a piece of the pie. Piece at a time. Before you know it, you'll be eating the whole pie.
So like we're learning to be competitive eaters. We eat one piece,
Joey
and then
Chestnut,
slowly
you're
get
up.
more piece until we can eat one pie at a
I'd
time.
love to have a.
And then we eat multiple pies at a time. And
You
just
got it.
keep going.
So, questions?
Why is it 24?
I'm licking my lips, but it's under the mask.
That's an excellent that comes out.
Yeah, that's what you get in the
I can't say that.
calculator.
No, I didn't say that.
Okay. Yeah, this does bring up a good point. Please make sure and add these at the end. If you're not, you're missing it. How's everybody feeling right now? You get why we're doing what we're doing?
That's a lot of.
I feel good.
That's a
I feel
big
good
number.
about this.
I did that.
Genuinely.
That side's quiet.
I'm saying.
How y'all feel? Y'all feel good?
I couldn't do it by myself.
Feels good.
Where you lost it? I'll tell you what. Let's do this. This'll be good.
Do you want to buy ourselves?
No. I think I could do one by
No, this is what we're gonna do. You're gonna walk me through it. Now, do me a favor.
Hold my hand.
Listen, Mr. Hall says this many times. You walk in this room, leave your pride at the door. Those of you that know what's going on, you're speaking, you're involved, you're like, you need to set this here. I'm gonna ask you to do me a favor. Just be silent for this moment.
Okay.
For those of you that don't know what's going on, I'm looking for you to get, you haven't been here, that's your problem.
You're not gonna know.
No, I've been here the whole time.
Whenever I write out 6.022 times 10 to the 23rd, and you're like, what?
I
Where did that come from?
I said excuse me. I didn't say what.
How big numbers go big long?
I want you to get involved, because once I start hearing you talk, it starts letting me see where your thought process is. We have to fix the thought process. I can't come into your brain.
What if I got it already?
You have to open your brain
Then be
to
quiet.
me.
What if my brain's working? What if I'm smoothing? I think I got this, Mr. Hall. I got one wrinkle gone, and it's for this.
Do you want us to write this down on this paper?
Yeah, I want you to do it, but I just don't want you to necessarily say anything. Okay.
I have one question.
Yeah.
When it says molecules, do we always use that same number?
Yeah.
Yeah.
Let's go. This gonna be easy peasy. Lemon squeezy.
Give him a hard one, please. Just shut him up.
Give him the hardest one you can.
Do it.
You should have seen the one we
Let's
did
go
yesterday, Andrew.
I'm talking about him, not y'all.
Of. Can't do that.
Go back to propane.
We're not doing propane.
Propane.
Let's do
Ain't
methane.
Hill.
Methane.
I thought you just said math on me.
Then I have to say.
I have no idea what that
from
means,
me,
Mr. Hall.
not for you.
Oh no,
Methane, Andrew.
I no longer know what I do. This is scary.
My problem is I need to memorize those. No. No. Yeah.
Yeah, you don't gotta memorize these.
Well, what are
It's on
they?
your period, top of
No,
Yeah. Listen, look, hold on. I want everybody to hear me. I don't expect you to memorize this. Okay? You all knew this was water. That doesn't matter. If I gave this to you on a quiz, I'm going to tell you where hydrogen is, I'm going to tell you where oxygen is. I'm going to give you the numbers. And the reason I do that, I don't expect you to know them right now because we haven't done nomenclature. Whenever we go into the periodic table, I'll give you an element quiz. I'll tell you the elements you got to know beforehand. You will learn them, and then from there we build on top of those elements and we do nomenclature. So I don't freak out because of that. Don't worry about that. I don't expect anybody to know that's methane.
Well, now I do.
Or N, 78.3 times 10, third power. Ooh. Why not?
Grams of lettuce.
So I would give you something like this. Like I'd say C, atomic number 6, H, atomic number 1. And I would give you that to tell you where it's at on your periodic table. Now, you all walk me through the problem. What's the first thing we're going to do?
Find your number.
Find where we're starting and where we're going.
Ah,
Where are we starting?
at the number.
No, mass, no. I don't know.
We're at mass. How do you know it's mass?
Because kilograms.
Because of the kilogram. So this is my starting point.
Do you have to
Cool.
bring kilograms down to grams? Okay.
Oh, the
Yes,
starting
no.
point is because of the chart
Okay,
thing
so
you
you're
gave
not
me.
metric.
Smart people don't answer it. You're not allowed to answer.
Okay, where are we ending?
Molecules.
Smart people don't answer.
We're not answering. He hasn't even been here.
I haven't been here, bro. This is my first day. Come on. Let me get into it. I gotta get the flow. I gotta get the zen.
Okay. So, already, I threw a trick in here for a reason.
Uh-oh.
Do you see it?
No.
Hang on.
I want to know if there were 17 tricks in
Smart people, hush.
I'm gonna fight you.
I have a question. You know we're at mass, right?
there. Yes.
When we go to mole, because we're going to have to go to moles first, right?
Yeah.
Sure.
So whenever I do that, what's the units of the conversion factor?
Yes.
What's the units that come off the periodic table?
Average atomic.
Units.
I don't know.
For
Units?
what?
For the average atomic mass, for the molecular mass. Okay. Let's do this. Let's write the number down.
I don't know if I've ever any of this down.
So 78.3 times 10 to the third power kilograms of methane. Set it over 1. Now, formulate a plan. You said we're starting at mass and we're going to molecules. Can I go straight from mass to molecules?
No.
No. What do I have to go to first?
If you're going from mass to molecules,
What's the name of this conversion? Mole conversion.
at a mole.
The reason it's called mole conversions is you're either starting with, ending with, or going through moles.
So you put it to moles first, and then you use that answer to go to molecules.
So,
That's also Spanish.
so hey, do you get that you can't just go from mass to molecules?
Yeah.
Where do you gotta go first? So we gotta go to moles. So, step 1, let's go from mass to moles. I need a conversion factor. What's the conversion factor?
1 mole over
Something gram. So it's grams of methane. Here's the thing. This is what's wrong. look at your units. Here, it's grams. What is it here?
Kilograms.
Portland, I see a signing out.
Those are not going to cancel out. They're not the same.
So why don't we use kilograms then?
So you have to do something. You have to do a metric conversion and get it to grams. So if you need to, set it up how I set them up.
Are we going to grams because it doesn't have like it's a base unit and not a prefix?
You always use grams with mine.
It's always grams because everything that comes off the periodic table is in grams per mole. You really should not miss. I've said all this.
Well, Mr. Ross,
I think I might have got it.
sometimes we just don't want to write.
I would look at it and have no idea what the answer is. Okay, so 78.3 times 10 to the third power kilograms equals how many grams? So now you got to do the conversion. Do my method. 78.3 times 10 to something or another. Kilo, exponential value for kilo is 3. Minus exponential value for the base unit, gram, 0. So that's 3. There's nothing on the exponents. There's no exponents on the units, so we don't multiply by anything. But I did start with a 3, so I have to add that 3 here. That'll give me 6. So 78.3 times 10 to the 6th power. So change this. Take kilograms out. We're now in grams. As soon as we take that 3 and make it a 6. Y'all see where I made the change? Why I made the change? Because now look what happens. I have grams of methane, grams of methane. They'll cancel. Now comes the fun part. Can I just grab the periodic table and know the number for this like that? No.
Probably not.
Will I use the periodic table?
Maybe.
Yes. We have to find methane's molecular mass. So let's find methane's molecular mass. What's the 2 elements in methane?
Carbon and hydrogen.
Carbon and hydrogen. How many carbons?
1.
How many hydrogens?
4.
Multiply that by their average atomic masses. So carbon, if I remember right, is 12.01 grams per mole. And for hydrogen, it's 1.01 grams per mole. I remember that. I don't expect you to remember that. That's why I give you the periodic table. How's everybody doing?
I think I might have.
Yes.
So when like you have the CH4, it's just 2 letters off of that? Oh, no. Periodic table.
The C and the H.
What
Yeah.
are we doing before?
That's the number. So there's 4 hydrogens. That's where the 4 came from. So this 4 came from here.
And it makes methane.
Okay.
That's what you said it makes, yeah. That's not very important.
That is methane. That's the molecule.
Well,
of methane.
yeah, that's what, it makes up methane, I guess. Well,
So
it is methane.
12.01. I really didn't need a calculator for that. I don't know why I did that.
Yeah, come on, Mr. Ball.
Alright, we add these guys together to give me 16.05 grams per mole. Y'all getting that?
No.
Yes.
So we multiply the 4 by the however many grams we have?
1.01.
And then we add it with the carbon?
Yes.
So you basically just, so you just take as many and then add them. That's about it. That's what I figured.
How we doing?
Pretty chill.
Is that to this problem?
Is that what?
Is that to this problem? CH thing?
Yes. That's to find the molecular mass.
This looked a lot harder than I thought.
What am I doing?
It actually is.
Oh.
Okay.
So far, the worst part about this is having to do with
Why did we do that? so that we can put this number here to get to moles of methane.
Yes. So basically this is just, you gotta remember which step to do when. Which is like every other math ever. But this is a lot of steps and a lot of different wins.
Yeah.
So as long as we got that, then it's an easy game.
I'm about
You
to
sleep a
quit.
lot?
Is that all you have to do?
I'm about to quit cheering everything.
What do you mean, Dustin?
There ain't no quit cheer.
I
I'm
never
about
sleep a lot.
to.
All right.
It's left us.
So that number, that 16.05, goes here. Now the grams of methane cancel. Are we finished?
No.
At this point, my units is moles of methane.
No. Unless I'm wrong, and then it's yes. But I think it's no.
Not you multiply something. Don't we multiply the top with the bottom? Yeah.
I want to show you.
In this case, no. This you would divide
Why would you divide?
because this number's in the top and that number's in the bottom.
So if they're on the top, both of them will multiply, but if they're on the bottom, they're divide.
Yes.
Okay.
So am I done after I do that?
No.
Why?
Wait, you told me to shut up.
Well,
I'm
we got our
sorry.
answer.
What's our answer going to be? Where are we stopping? Where's your stopping point?
No.
So we're going to stop at molecules. Are we at molecules?
No.
No. We're here. We're at moles.
Michaela Browning and Allie Laney to the office, please.
So mole is basically just like the in-between of everything.
Wait,
So once you get to that, you can like,
Multiply or divide that 16.
Divide by 16.05. I'm not doing that yet, so I don't know what number you're going to get.
We
A very large one. Yes.
chemicals except
A very, very large one.
drinks and stuff like that. That's what
Okay, I'm skipping that.
Okay. We need another conversion factor, right? Why? Because we're not in molecules yet. So I'm in moles. I'm here. I'm trying to get to molecules. So can I go from moles to molecules?
Yes.
Yeah. So I'm at moles. I'm leaving moles. What does that mean? Is moles on the top or the bottom?
On the top.
leaving Moses on the
On the bottom. Nice.
Bottom, on the thicker one area.
You're okay.
they tried to teach me this in Algebra 1 and I didn't get it, but now for some reason I've got it. So that's cool, I guess.
Nice. What's going to go in top?
6.022 times 22.
What's that number?
Oh, I can't pronounce
Have a God rule.
As we call it, avocado.
Nah.
Nah.
So molecules of methane. Do you all see why we did that? Why the conversion factor is set how it is and all that? Talk with me, ladies. I know I'm making you very uncomfortable.
I mean, I understand, like,
I get where that number
I'm getting it there.
Okay.
I was
That's why we keep going through. Okay, so moles of methane will cancel, right? Now am I done once I punch it in a calculator? Yes or no?
Yes.
Yeah.
I've heard a no, I've heard a yes.
I think
I'm gonna throw it out
If
there.
they cover all answers, they have
I'll
to.
question you. What's the units I'm looking to end up with?
Molecule.
Molecules.
Okay, molecules of methane. What's the last thing I got?
molecules methane.
You're done. Let's punch in the calculator. Please do me a favor and punch this in the calculator. Make sure you punch in the calculator properly.
Okay.
Oh,
Oh, there's so much stuff in here on my calculator already.
Oh, you already stick that hair on this.
Are we dividing or multiplying?
This number is in the top. This one's in the bottom.
Multiply.
Divide.
When you
If
divide
they're in
that.
opposite spots, it's divide.
But don't you multiply the others?
Now this one will be multiplied because it's in the same spot.
That's what I thought.
So you divide that one, and then
Got a really
multiply
long
the
number.
answer to that.
Yeah, I got a
Okay.
really long number.
Oh, that's gonna take a minute.
This number scares me.
4878.
It's second.
Woo! Man, what a number.
I got a
Hold on,
yeah, it's
don't
a very
worry,
large
hold on.
number.
What?
Very one more.
Where'd you
I forgot to write this down when he's standing in front.
What'd you get with it? I don't think that's right. No,
4878.
I messed it up. I didn't do it all at once. Like an idiot.
And then we times that by the,
I did it bad, didn't I?
So that's the answer you should get. You should get 2.9378 times 10 to the 30th molecules of methane.
That's hard. Which one first?
So I think
What I do is I just do like 78.3 E6 in parentheses,
Yeah.
divided by
I actually use
6.05.
scientific notation.
Then I just times the
So I
answer
take
by
78.3.
6.02 times, well then
And
23.
divide
You can do that,
by
or you can do multiply first and then divide, or you can do
Yeah,
multiply or
78.3
divide that one by that one. and then
E
multiply that one. Doesn't matter.
6
Yeah.
and parentheses.
If you don't get up from me, you can just watch me, but I'm sure you'll understand.
When we do these and get big numbers, do we
Probably the
like,
easiest way to do it is to divide the
and
left
then
by the
E.
middle. Yeah, and multiply those. That's probably the easiest.
yeah, do we do
Yeah.
One step.
Okay.
This is what I'm saying, this is what I did. Parentheses, 78.6. Now, that's times 10, so I go second.
I got it, Mr. Hall.
On the calculator. You know, I go this column. See that E? The E takes place in times 10. So now you just type in the number. What's
I'm
that?
lightheaded now. I strained too much.
That's like this end
So
of
it is 6
1 second.
in the parentheses. So now that one's taken care of.
No, you
It's in the bottom, so I'll divide.
Should get 4, yes.
Divide.
I got it.
16.05 in parentheses. And I'm gonna multiply, and you type that one, just do times.
It's still
we
40.
got an issue.
Big attention.
I got 47. I didn't even know for it.
I think we can.
No,
Where did you get 78.6?
in the what?
From
I don't want to.
Austin.
Oh, I got the right thing the first time. I gotta get riled up.
I don't know yet, but it's coming.
Yeah.
Hold on. Shoot this camera.
Whatever.
We're doing that for work probably. We have lunch Friday.
Exactly.
Why is there chunks in it?
I want to get a deep
There's
sleep.
chunks?
All up here.
Is it fermented?
Alright, hey, we're gonna do something for a second. If you are struggling with how to punch this stuff in the calculator, y'all gonna get around me right here.
Yeah, I can do that.
I want to do it by myself. No, I already got the calculator. I just want to do it proper.
Alright, this is what I'm doing.
You know how you took the bike
So first thing I'm gonna do, I'm gonna get the
Is
parentheses.
that two coming out?
Yes.
I got this
Double
on.
check it.
You guys are struggling with how to punch this stuff in.
I did it.
Can I use the bathroom while you're doing this?
You
How
can.
does it round up to that?
78.3. Is the second. So right there you should have 78.3 E. And then E takes place at the time. So the next number I type in,
The berry one's not.
that's gonna be the exponent. So we get 6 in parentheses. That calculator now reads that as what I have.
I got that, but I didn't type it.
Then, that number's in the top, my next number's in the bottom, so I divide by
So much smaller. Unless you
16.05.
didn't type as much in.
And then, in parentheses, I'm gonna multiply by Avogadro's number, which is 6.022 E to the 23rd.
So you start off with your 7.3, but then you do the E,
And hit enter,
and you hit 6, and then you finish your parentheses.
I'll remember 6.02, about Carter's number.
16.05.
I think I remember.
John.
Yeah, thanks to you.
hey, the whole thing with the avocado number, I'm cool with that.
23. And then you
Alright, look. Yeah. Thank you. I want y'all to do me a favor. I want you to get your periodic table out. I'm going to give you, there's one last thing we're going to do to finish this lesson. I'm going to introduce you into the one thing. You know how I told you cubic centimeters is a trick that stays in my back pocket? I have 7 others I'm going to add today. Today. And I'm going to do it in one fell swoop.
trickle them in, you know?
I just laughed.
Oh,
I'm so stupid.
So, in
More tricks.
the
Want
urn,
an index card?
we have something very special.
Gravity.
There's a very special group. These are like the Avengers.
I prefer to call
I
it.
introduce you to
Megan Mitchum, come to the office. Tomorrow is the last day to order a homecoming t-shirt before lunch. If you know of someone that's in quarantine and they want to order a t-shirt, have them get in touch with us here in the office before lunch tomorrow. Wednesday, September the 29th, we will be taking homecoming court, student council, and class officer pictures.
So, the 7 diatomics are 7 elements that, the definition of diatomic, are elements that exist in nature bonded to themselves.
Fire.
So here's the thing that makes this a trick. You've heard of oxygen. Oxygen is a perfect example. On the periodic table, you see there for oxygen where the average atomic mass is 16.
Yeah.
If I give you a problem and I say the word oxygen, oxygen is a diatomic. So oxygen is equal to O2, which means the average atomic mass is double. So 32.00 grams per mole. This applies for all of your 7 diatomics. I'm going to show you a trick using your periodic table. It's going to help you. All you have to do is remember these 7.
Okay.
And you have to remember the number 7. The number 7 is very useful. I'm going to try something. This may go awful. So, I bet I'm pretty loud right now. So, the first one you're going to look at of the 7 diatomics sits by himself. He's lonely. He's Mr. Lonely. He is hydrogen. Hydrogen is the first of the 7 diatomics. Now, here's the trick. You're going to love this. There's 6 others. But those 6 form the number 7 on the periodic table.
What?
The nitrogen?
Is the start.
Nitrogen, oxygen, fluorine, neon, argon, krypton. Oh, the wrong way.
So, you're looking at nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. All. It's technically iodine, but a lot of people call it iodine. If you do, that's fine. I don't care. But these are your 7. This is why it's a nice little trick. It forms a 7 on your periodic table. Only thing is you have to remember hydrogen's weird and by itself.
Why is hydrogen weird about itself?
Well, it just decided it wanted to be that way.
Hydrogen is crazy.
Now,
Question is how who came up with that one? That's what I
well, funny thing is, it just happened on the periodic table. These 7 they exist in nature, bonded to themselves. Like I will go on and tell you, does anybody in this room, there's some of you that should, know what the most stable bond on the planet is?
No, I'm not going to say.
A triple bond.
Of
Hydrogen.
Hydrogen.
Or covalent.
Oxygen.
Covalent or hydrogen?
Sunflower.
nitrogen
Ah.
is the most stable bond
I think we
in the
told us that.
Oh,
universe.
yeah, you did.
Nitrogen bonded to itself.
We failed you.
So,
If that was
when
tricky.
you come in here tomorrow, we get to kick this up a notch. Remember, Friday you have a lab. Tomorrow, we will kick this up. I'm going to give you some practice problems. I'm going to let you work some practice problems in the room with me here, with people around you. And we are going to finish up mold conversions. Have a great, wonderful day.